Hello everyone, this is Prasanna Patil, working as Assistant Professor in the Department of Computer Science at MIT Mysore. Now we are into the lab program number 9, K nearest neighbor algorithm, KNN algorithm. So we'll look into what is the 9th lab program, and then you write a program to implement K nearest neighbor algorithm to classify the iris dataset. Print both correct and wrong predictions. Okay, so we are implementing here K nearest neighbor algorithm to classify the iris dataset. We are working on the same dataset. We have seen this in the 8th lab program, that is K means and EM algorithm. So K means and EM algorithm regarding the lab program number 8, those are clustering algorithms. K means is a clustering algorithm, it is unsupervised algorithm, but KNN algorithm is supervised algorithm, and KNN is used for classification here. So we already know that what is a supervised and what is unsupervised. Supervised algorithms take both input as well as output for training, but unsupervised algorithm take only the input. It will not take the labels of the inputs. That is what unsupervised algorithm. Now look into what is KNN algorithm briefly. So KNN algorithm here. So we have few data points. Data point 1, 2, 3, 4, 5. These are all belong to one category, that is yellow category or class A, and 1, 2, 3, 4, 5. So these 5 data samples belong to the violet category, that is class B. So if I want to classify my new data point, that is star, into yellow or a violet, means class A or class B, so I need to look into if I follow this K nearest neighbor algorithm, then I need to find out what are my neighbors. So if I want to find the which class this data point belongs to, either this or this, or either class A or class B, I need to assume K is equal to some number. If I assume K is equal to 1, 2, 3, 4, 5, 6, I may get different answers. For example, here I have taken K is equal to 3. If I take K is equal to 3, 3 means 3 nearest neighbors, then this data point belongs to which class? Class B or class A? Obviously it is class B, because the shortest distance from this point to its neighbor, how many are there? 3. Because I have taken K is equal to 3, I need to consider the first 3 neighbors. So this is 1, this is 2, this is 3. Okay, the 3 neighbors. Out of 3 neighbors, how many belong to class B, how many belong to class A? So in this way I can classify a particular data point belongs to which class. So this is what, when I increase K value to 6, I need to consider all this. So here if I consider K is equal to 6, out of 1, 2, 3, 4, 5, 6, out of 6 data points, 4 belong to class A and 2 belong to class B. Now this data point belongs to class A, that is yellow color. This is what. So how to decide the one more question arises, that how to decide the value of K. Then we'll look into the algorithm first, and then we conclude with how to choose a value for K. When do we use KNN algorithm? So this is what the question. when do we use? As we already know, it is a supervised algorithm. It is used for KNN algorithm is used for both classification and the regression. Okay, for the predictive problems like classification problems and the regression problems, we can use this KNN algorithm, and it is most widely used in classification than regression in the industry. The problems, whatever the problems arises in the industry, uh, those are solved in those are classification problems, and for the classification problems we have used KNN algorithm. Okay. To evaluate any techniques, we generally look at three important steps. Whenever we want to solve any problem, we look into these we evaluate the technique into these three important aspects. The first one is ease to interpret the output, second one is calculating time, and the third one is predictive power. So based on this, we evaluate the algorithms, how powerful they are. So there are examples of algorithms for classification, because we are into the classification now. So few algorithms, namely, one is logistic regression, second one is CART, third one is random forest, and the fourth one is KNN. So we have taken three important aspects, that is first one, second one, and third one. So the first aspect is easy to interpret the output. So having the highest is CART and KNN, and the next is logistic regression, and next is random forest. Calculation time is highest logistic regression and KNN, and the next highest is CART, and the least one is random forest. Predictive power goes to random forest, and the next all are same. So considering all these aspects, which one is better? Then all are classification algorithms. Which one is better? Yeah. KNN algorithm fares across all parameters of the considerations. What we have taken the parameters, if you consider all these, KNN algorithm fares across all the parameters. It is commonly used for its ease of interpretation and low calculation time. So people use KNN because of its ease of interpretation and low calculation time. And you might have heard about logistic regression. Logistic regression is not a regression algorithm, it is a classification algorithm. Even though the name is regression, this logistic regression is nothing but sigmoid activation function. You might have heard about this in fourth lab program, that is neural network artificial neural network backpropagation. There we have a formula called as 1 divided by 1 plus e to the power minus x. This is f of x, right? Okay. Where the outcome is always okay. This is minus 0.5. This is plus 0.5. Okay, the outcome lies always between the two boundaries. That is the classification. I just briefly explained what is a logistic regression. Then CRT algorithm. It uses the decision trees, and we already know what is a decision tree. We use decision tree for the classification as well as regression, but mainly used for classification problems. And CART is one of the algorithm which use decision trees. And random forest. About random forest, it builds by a random forest can be built by ensembling the decision trees, means group of decision trees. And random forest, it builds several decision trees by randomly selecting observations and features. So it builds several decision trees by randomly selecting observation and features. Forest is nothing but a group of trees, right? But it is doing it randomly selecting the observations and the features of those. What is the difference between the random forest and the deep? There are some disadvantages or problems in decision trees. Whenever we go with deep decision trees, the deep decision trees suffer from overfitting. Okay, then this problem can be solved by random forest. Like, this can be prevented most of the time by creating the random subsets of the features and building smaller trees using those subsets. This is what random forest, and how we can solve the problem of overfitting when we get into the deep decision trees. Okay, and then KNN, we are now dealing with the KNN. We look into what is KNN now. These are the distance formulae. We have already discussed about the distance formulae, formulas, and in our 8th lab program. Just go through the different distance formula what we can implement. We can implement any distance formulas. Okay, the most feasible is Euclidean distance. So k nearest neighbor algorithm, how it works. So see, here is already classified model. We have classified these into category number 1, and we have classified these into category number 1, and before categorizing we need to plot the data, and this is a built model that which classified the category 1 and category 2 already. And if we insert a new data point in the middle, if I want to classify whether this belongs to category 1 or category 2, if I use the k nearest neighbor easily does this. Okay, this belongs to category 1. Okay, how it does it, how the KNN does this, how it classifies this, that is what the question, and we need to look into it. How did it do that? How did KNN do that? This is algorithm. Just go through the algorithm. I'll be explaining the algorithm in step by step in the next slides. We choose the random k by default. K is equal to 5. K is equal to 5 or 3. Mostly it is 5. I am not sure it is 3 or 5. We need to look into the when we are into the program. We'll just go through what is the default value of k if we don't initialize it. Okay, then take the k nearest neighbor of the new data point. Take the k nearest neighbor what we have assumed according to the Euclidean distance. Making use of Euclidean distance, we need to consider the first nearest k values, and then among these k nearest neighbors, count the number of data points in each category. Means if there are 2 categories, how many data points are from category 1, how many data points are category 2. Then the majority category, the data point belong to the majority category. Now this is what we need to, this is how we classify the new data point. Choose a number of k neighbors. Okay, it's a 5, and I need to classify this data point belong to which category. So what I need to do, I have already assumed k is equal to 5. Then I need to find the distance from this data point to all the data points, distance from this data point to all other data points which are already classified. Okay, and once I compute the distance from all the data points, available data points, I need to take 5 nearest data points. whatever the 5 nearest first data points, I need to consider those. So how do I find out the distance? Suppose this is point P and denoted by coordinates x1 and y1, and this is a point P2 and denoted by the coordinate values x2 y2, and if I use the Euclidean distance, then I need to go with this formula. So this is how I need to calculate the distance. After finding the distance, what I need to do, I need to find out 5 because k is equal to 5. So see here, it is very clear that out of 5 data points, 3 are found red and 2 are found green. So it is very clear that this data point belongs to the red category. Okay, 3 neighbors and 2 neighbors, and this data point belong to this. But who specifies the value of k? I just took k is equal to 5 in the beginning so that I can explain it for the simple explanation. But who specifies the value of k? Okay, whether to take k is equal to 5, 3, 1, 7, 9, what value? Why I am taking odd numbers? Because I should not end up with the conflict that 4. If I take 8, if there are 4 data points belong to one category and another 4 data points belong to one category and another 4 belong to next category. So if I take odd number, then it's very easy to classify me which category the data point belong to. Okay, the first point is k in KNN, the number of nearest neighbors to examine, right? It is supposed to be specified by the user. So how can we choose the right value of k? This is what the question we have. Third one, the general solution is to reserve a part of your data for testing the accuracy of the model. So we are splitting the data. So this is very important. Okay, this is very important that we are splitting the data into training and testing. We are doing the same in our program. So that's why we are splitting the data using which method? Train, test, split method. Okay, in 9th program we are using train, test, split method. By from where we are importing this? We are importing this from cross validation or the model selection, any one of the module which we have. We got to know this. Then choose k is equal to 1, starting from the 1. Use the training part for modeling and calculate the accuracy prediction using the samples of your test set. If you have already developed a model, then start predicting the accuracy from k is equal to 1. Repeat the process means increase the value of k 3, 5, 7, 9. So whatever by increasing the k and see which k is the best suited for your model. Means accuracy. If the accuracy of the testing example is higher, then we stick on to that value of k. So this is very simple, right? But we need to look into all the k values, and this is how we choose the value for k. And finally, we should know that what are the modules we are importing in the 9th program. We import sklearn. So everything is in small case. sklearn, it has the first dataset, sklearn.datasets, and from sklearn.datasets I'm importing. So I'm importing the same dataset, that is load iris. Okay, so all the datasets are in this module, datasets. Next is I need to import the KNN KNN module that is present in neighbors, NEIGHBORS. As remember, neighbors spelling is not BOUR. Don't make spelling mistake while typing the program. It is not a neighbor, it is neighbors, and U is not there. So from sklearn.neighbors you import. What I need to import? I need to import KNN, not KNN, KNEIGH. Here also BORS, K neighbors classifier, CLASSIFIER. K capital, N capital and C capital, all others are small case, and there is no U here also, and this is neighbors, not neighbor. So this is the second module, and the third module was dataset is over, neighbors is over. Okay, I need to import test train, right? Okay, if I want to import test train, then I need to look into, first I'll write test train. Split, all are small, and I have two modules from which I can import this. Cross validation. Second one is model selection. Okay, in your program, if this works, then well, you continue with this. If it doesn't work, that means test train split is not defined, or some you get, if you get any error like no module is defined in kind of cross validation, then go switch the module name, model selection. In the previous versions, I mean in the older versions, this has been dropped. In the newer versions, this is included. Okay, this has been depreciated and this has been included. So if it works, if it didn't work, you go with this. If it didn't work, you go with this, and don't make any spelling mistakes. I have already told you, use just type the first letter, like from sklearn dot, then press a tab, you'll get list of methods. If you know the first letter, if you know the methods first two letters, then just type CR, then that will be popped first in the list, and you can just press enter to select the module. Simple. And that's it. This is we have one more thing, is sklearn from sklearn. No, it's import sklearn dot metrics. As we have taken SM, that means S for sklearn, M for metrics. Okay, this is just a alias for this metrics. And using SM, what we are doing, we are using this SM for two reasons. One is to find the accuracy, and second one to find the confusion matrix. Accuracy, okay, SM dot accuracy underscore accuracy score. Okay, accuracy score, and it has two parameters. And then the second one is confusion matrix. So your confusion matrix spelling is MATRIX, and this is metrics, METRICS. And again it takes two values, why do we need confusion matrix? So because in the question itself they have mentioned what is they have asked, we need to give a justification for correct classification and misclassification from the KNN. So if we draw this confusion matrix, then it will be very easier for us to give justification to the correct classification and misclassification. And that's it. We just move to the program. Okay, and this is regarding lab number 9, the KNN algorithm. We have around 15 lines of code. Okay, we started with sklearn.datasets, and we have imported load iris, and from sklearn.neighbors, no u here and no u here also. Here all the letters are small. Here K, N and C are capital. Cross validation, import train test split. I have commented here that if this model didn't work, then you need to replace it with cross validation. Okay, as I explained already. This is what and matplotlib. I have already explained what is matplotlib in lab number 8. Just go through it. Matplotlib inline. Okay, if in Jupyter notebook or in Spider, if you are not getting the plots inside the notebook or inside the Spider, you can use this line, percentage matplotlib inline. This line will make the plot to be printed in the IDE itself. I mean, it will not pop up a different window for the output, like we used to get the output in ideally. If you execute the programs in ideally, we used to get the output in a different window. So this will not happen here. Only if the output is not displaying inline, then only you use it, otherwise don't use this. Then I have already loaded the iris dataset in my computer and imported also. I need to just execute the constructor of this class load iris. What is the constructor of load iris? Load iris itself, but with a parenthesis. Okay, and that will be loaded into iris dataset. Iris dataset has now what it has now. One second, I'll just execute this line by line. So how to execute programs line by line in Spider? Just select the line and press Ctrl Enter. See here, I just selected the line and pressed Ctrl Enter. This line got executed. If you have any error in the program, you'll get to know right away, right there. And next I'll execute the second line, sklearn.neighbors. Oh, again no error. The third one and the fourth one I'll execute simultaneously. Control Enter. Okay, I imported everything imported, and now I'm executing the seventh line. Again it got once I execute this, I got this object over here in the variable explorer. We have three here: variable explorer, file explorer, and the help. In the variable explorer I got this. So if I want to know what is in the iris dataset, I just double click over here and I can see what I got here. See, as soon as I execute load iris will return what it will return. It will return description of the data set and data in the data set, what are the feature names, and what is the target names. Okay, if you want any details regarding these objects, you can just call iris underscore dataset dot data. If you call iris underscore dataset dot data, you can access this. So in our dataset we have 4 features: a petal length, petal width, sepal length, sepal width. Okay, so this is regarding data, and we have from 0 to 149, that means 150 samples. And if I want to access the targets of all the data samples, then I need to, how do I access? I need to access this target with the help of iris underscore dataset dot target. Dot target is also okay, or iris underscore dataset of target, because this is an index for this. If you want to access the whole thing is iris dataset. If you want to access this, you can use this as an index. So iris underscore dataset, like this, iris underscore dataset of data of target. Or the second way is iris underscore dataset dot data and dot target also. This can be worked as list as well as an object. List is an also object, but you can access these values in 2 ways. That is regarding data iris dataset. And next, once we get the data, and before we go to the KNN, what we need to do, as we already know, we need to split the data. Okay, test and train test split. We need to use train test split. We have already imported the module, the class train test split. Now I need to use the constructor of this class. So constructor is a method, it starts with parenthesis. So train test split, parenthesis open. So what the method is taking? The method is taking train test split. The first argument it is taking the data, the second argument is it is taking the target. Okay, this is the data and this is its target, and the random state is equal to 0. If you want to know about this, then press see. And I want to know about this, I need to click on here and control I. I got train split. What it does, I'll get to know. I got to know that see how do I get to know? I need to click on this train test split, then I need to press Control I. Okay, once I press Control I, the information of this method or this whatever the class or object will be displayed in help. And what is train test split is taking? It is taking test train size. What is the training size? What is the label? One second. It is taking input, that is this is the data and this is a target. Means I to equally distribute the data set into training and testing. And next it is taking a random state. Random state is pseudo random number generates a state. Generators pseudo random number generator state, use it for random sampling, randomly sampling. We are using this parameter stratify. And then what it is returning, splitting length is 2 into arrays list containing train split inputs. An example is here Okay, uh, what is the sequence the method is returning? I mean, what data it is returning, and what is the sequence? The sequence is always x x y y. You just remember x square y square. If you make change, or if you write ulta something here, then your program will not work. Clear? So this is x train x x y y, and then train test train test. This is the order this method is returning the value by processing the data and the target. Simple. And once we get into once we partitioned our okay, if we didn't partition our data, if we didn't mention the what partition we want training and testing, by default it is 0.25, means 25% of the data will be used for testing and 75% of the data will be used for training. If you want different portion of training and testing, you can change it. So you can change it by mentioning test size is equal to 0.30. It will be understood that training size will be 0.70. If you mention train size is equal to 0.60, it is understood that test size is equal to 0.40. So if you mention any one, it is enough. And then, or you can mention both, that is also fine. Then we are done with the x train and x test for the x train and the x test for the x train and the y train for the training purpose. We need to use x train and y train for the training purpose. But to train, what I need to do, I need to have what? A k neighbor class. Okay, so I need to get this. I need to call the constructor of neighbors classifier. Here is the constructor, and I have created an object. Using this object, what I am doing, I am just fitting my training data. What is the training data? So it is train. Don't take x train and y test. Don't take x train and x test. It is always x train and y train. X is the input, y is the its label, but both are training, for training purpose, because we are fitting these two to train the model. Whatever the after training, kn will be having train model. Clear? And we can also write in this way also. Instead of writing two lines, I can write kn is equal to kn dot kn neighbors classifier, and then I can take fit. See here, cannot after this press a dot and press tab. Then the methods will be listed here. Which method you want to take, you can take fit. Then in the fit, it is asking for two arguments, x and y. No need of declaring self. X and y are x. You just press x and press a tab. It will suggest you the objects or variables starting with x. I need to use train or test. I am training here, right? I need to use x underscore train, and then I need to specify the second argument, y. So I need to use y train. So y, and I typed capital Y and I pressed tab. It is not suggesting anything, means there is something went wrong. That is, I need to use a small case and press tab. It will suggest me y test or y train. Y test or y train. I'm training here, so I need to use y train. So I can use any of these lines. I'll just make it as comment. And I made a model, and using the same model, I need to predict what? I need to predict for testing examples. What is the label? That is y test, right? What is the label? Predicted label. This is already existing label. What I need to do now? I need to predict something from the k nearest neighbor. And k nearest neighbor, what is the default value of k? N neighbors is equal to 5. If you want to change the value of n, k, that is just is equal to, you can make it as 7, and here also you can make it as if you make it comment, it will not work. NEIGHBORPORS is equal to 7. You can make it as 7. Clear? If you do not specify, the default value is 5. And I'm passing x underscore test because I want to predict the label, and I want to compare my predicted value with the y test and the prediction. I want to compare. So now the training is over and the prediction is also over. Then what I need to do now, I need to calculate the accuracy score of my KNN algorithm for a given data set. So accuracy of KNN is sm.accuracy score. I have already explained what is sm. Sm is alias for matrix. Sm.accuracy score, it takes two parameters. One is y test. Y test is already existing label, and versus the predicted labels. And okay, once I display the accuracy, then I'll go with confusion matrix. Confusion matrix also takes y test and the prediction, means already existing labels and the predicted labels. And then I need to plot a graph to show the prediction of data samples to specific classes. That's it. And here plt.plot, it takes x and y, and this is the pattern which I want to represent the specific data points on the graph. This is R for red, O for circle, and this is a string. If you miss the string, it will throw error. Clear? And plt.plot, this is for x test versus y test, and this is for x test versus prediction. This is for x test versus prediction. And next is, okay, I executed programs up to the statement up to here, and I will just execute the whole thing step by step. Home, then control enter. Okay, this line got executed, and I'm executing these two lines. That's also fine, no error in it. Shift and enter. Okay, I just got my predicted values, and now importing and accuracy, enter. Okay, I got the accuracy as 97%, and now I need to execute this. Control enter. Okay, I got the confusion matrix also. Now I need to execute this. I got a plot for actual values, and now I need to execute. Now I got this is predicted value. Okay, this is for actual value, x test and y test. This is a graph for actual value. Okay, and the second is the predicted value. If I execute them separately, I'll get different graphs. I mean, this is represented with red with circles, and this is represented, one second, this is represented with dot. If I execute both of them parallelly, then I can get to know that which is a correct classification, which is a misclassification. So, this is regarding KNN, and okay, I'll just execute this. Yeah, confusion matrix for KNN. Confusion matrix tells us what is the correct classification and the misclassification. As I already explained, how to make this. Okay, the decision of the confusion matrix. The first row belongs to Iris setosa, the second row belongs to Iris versicolor, the third row belongs to Iris virginica. And the first row, first column is Iris setosa, second row, second column is Iris versicolor, the third row, third column is Iris virginica. So, I mean diagonal elements are correct classifications, and except diagonal elements, all other are misclassifications. So out of how many are wrong and all, we just look into it. If you add all this, what is the sum? 10 25 38. Okay, so out of 38 I have used 150 data samples. Out of 150, 38 are used for testing, and left out are used for training. That is 112. Right, 112 are used for training, just 38 are used for testing. So out of testing, how many are right and how many are wrong? I mean, how many classes are correctly classified, how many data samples are misclassified. Out of 13, all 13 are Iris setosa. Okay, out of 38, 13 are Iris setosa. Out of 38, 16 are Iris versicolor. Out of 38, 9 are virginica. Okay, but what is the right classification, what is the misclassification? Out of 13, 13 are classified correctly, 0 are classified wrongly, and 0 are classified wrongly, right? Out of 15, out of 16, 15 are classified correctly, 1 is classified as misclassified as virginica. Out of 16 versicolor, 15 are classified as versicolor and 1 is classified as virginica. Out of 9 virginica, 9 are correctly classified and none of the data points, none of the samples are wrongly classified. Finally, what is the difference between lab 8 and lab 9? The programming difference. Okay, you should remember this. In lab 8, lab 9, the algorithm is k nearest neighbor. K nearest neighbor is supervised. That's why it is taking two values. One is input and next one is its label. Okay, to train the model, one is input, then its label. And in 8.1, which algorithm we are using? We are using k-means. K-means is a unsupervised. That's why what we are doing while fitting, we are only using x. We are not using the label. And here also we are only using x while fitting. We are not using any label to train the model in k-means because it is unsupervised. And that's it. Thank you.